Hi everyone, this is your math guru. In this video, I'm going to show you how to expand the following algebraic expression using binomial theorem. Please don't forget to click on the like and the subscribe button below for more easy to understand math concepts. In the first example, we have x plus 1 all raised to the power of 4. Using the binomial theorem states that if I have x or a plus b, that's equal to the summation. A plus b is raised to the power of n, so we have the summation from r equals to 0 to n. We have n combination r, a to the power of, that's the first term, n minus r, and b to the power of r. So we're going to use this expansion to solve what we have. In this case, our n is 4, our a is x, and our b is 1. So therefore, writing it using the same sigma notation, we have that will be equal to summation. N is 4, so I'm going to write my 4 at the top. R is starting from 0. We have our n combination r, so that's 4 combination r. R is starting from 0 as shown by our sigma notation. Our a is x to the power of, n is 4, so we have 4 minus r. Then our b is 1, so we have 1 raised to the power of r. So we've used the exact same sigma notation as shown. The next step is to expand what we have. So starting from r equals to 0, we have 4r, that's 4 combination starting from 0. We have our x to the power of, note that because r is 0, we're going to have our first power as 4 minus 0, which is 4. And then we have multiplying 1 raised to the power of r is 0. Note that at each point in time, if you add our powers together, it must be equal to n, which is 4. So 4 plus 0 is 4. We have that as plus. We move to r equals to 1. So we have 4 combination 1, x to the power of. So what happened is the value of the exponent for x, or the first term, begins to drop, and the value for the exponent of the second term begins to increase. So the power of x is going to drop to 3, and the power of 1 is going to increase by 1. That's 0 plus 1. Like I mentioned earlier, the powers of our variables must always be equal to 4, which is our n. We have plus 4 combination. R is going to increase to 3, to 2. That's the next one. I'm going to change that to 2. We have x to the power of 3 drops to 2, then 1 increases to 2. We have plus, I'm going to move that to the left so that I can have our expansion in one row. Then I have plus, our r increases to 3, so that's for combination 3. X drops again by 1, the power, so 2 minus 1, that's 1. Then our 1 increases to 2 plus 1, 3. Like I said, a good check is to always make sure that if you add the powers together, it must give you n, and in this case, n is 4. Then I have plus the last term, 4 combination 4, x to the power of 0, 1 to the power of 4. And if I resolve what I have, that will be equal to 4 combination 0, you can get that on your calculator. That will be 1 times x to the power of 4 times anything to the power of 0 is 1. Then I have plus, my dot means multiplication. 4 combination 1 is 4 times x to the power of 3. 1 to the power of 1 is 1, plus the next term, 4 combination 2, that's 6, times x to the power of 2. 1 squared is 1, and I have plus 4 combination 3 is 4, times x to the power of 1, x, times 1 to the power of 3 is 1, plus our last term, 4 combination 4 is 1, times x to the power of 0 is 1, times 1 to the power of 4 is 1. And writing our final answer, 1 times x to the power of 4 times 1, that's x to the power of 4, plus 4 times x cubed times 1, 4x cubed, plus 6 times x squared times 1, 6x squared, plus 4 times x times 1, 4x, plus 1 times 1 times 1, 1. Let's look at the second example. In the second example, we are to expand to x minus 3 all raised to the power of 4 using our binomial theorem. If I rewrite that, that will be our a is 2x and our b is minus 3. So I have that as, using the sigma notation, summation from r equals to 0 to our n is 4 in this case also. We have 4 combination r as that changes. Then our a, note that is 2x. I'm going to put that in a bracket to the power of 4 minus r. And our b is negative 3 to the power of r. So writing out our expansion, I'm going to try and fit that in a row. The first one, r is starting from 0. So I have 4 combination 0, we have a 2x to the power of 4 times negative 3 to the power of 0. Note that our powers must always add up to n, which is 4 in this case. 4 plus 0 is n. Then I have plus 4 combination 1. I have a 2x. The power begins to drop, so it becomes 3 multiplying minus 3 to the power of 1. Plus 4 combination 2, then I have 2x to the power of, the power drops to 2, then I have negative 3 increasing to 2, I have plus 4 combination 3, then we have 2x, 4 minus r, 4 minus 3 is 1, then I have that is negative 3 to the power of 3, and the last one will be 4 combination 4 in bracket 2x to the power of 0, negative 3 to the power of 4. Another good way to check is if I subtract 4 from 0, it will always give you the power for the first term, that's your a. So we have 4 minus 1, that's 3. 4 minus 2, that's 2, 4 minus 3, 1, and 4 minus 4, 0. The next step is to simplify what we have. So that's equal to 4 combination 0 will give us 1. Multiplying, my dot is multiplication. 2x to the power of 4, that will be 16x to the power of 4 times any number of variable to the power of 0 is 1, so that's times 1. I'm done with the first term. Then I have 4 combination 1, that will give me 4. Then I have times 2x to the power of 3, that will give me x 3, times negative 3 to the power of 1 is negative 3, plus I have 4 combination 2, that's 6 times 2x to the power of 2, 4x squared, times negative 3 to the power of 2 will give me positive 9, plus I have 4 combination 3, that's 4, times 2x to the power of 1, that's 2x. Then I have that minus 3 raised to the power of 3 will give me negative 27. I'm going to put these two guys in a bracket because of the negative sign. Then I have plus 4 combination 4, that's 1, times I have 2x to the power of 0, that's 1, times I have negative 3 to the power of 4, positive 81. So therefore, my last line, which is my final simplification, 1 times 16x4 times 1, that's 16x4, plus 4 times negative 3 will give me negative 12. So I'm going to change my plus to negative. And negative 12 times 8 will give me 96. X to the power of 3. Then I have plus 6 times 4 times 9 will give me 216. X to the power of 2 minus, that's 4 times minus 27, that's minus 216. X plus 81. Thanks for watching. Bye.